For today, we're going to go through a little bit of review, and then we're going to explore the behavior of waves in different types of mediums. And kind of focusing on light. So you're going to need page 1.12 and 1.11. And I did kind of flip those around in your notebook. So it's kind of weird. We're starting with 1.12, but then we'll come back and we'll hit 1.11 in just a little bit. So to get us started today, we're going to be comparing and contrasting two different types of waves. Now, we've been living in the world of mechanical waves, and so what I want you to do is just take a moment to pause this video and just start listing out on page 1.12 on this side of mechanical waves. Go ahead and pause and start listing out some of the different characteristics and what you know about mechanical waves. And then when you're done, come right on back. Okay, so hopefully you have written some of these things down. And so what we've been learning over the last couple weeks about mechanical waves are going to include water waves, slinky waves, rope waves, sound waves. Seismic waves are included in mechanical waves, like earthquakes. And all of these types of waves have to have a medium to travel through, and they cannot travel through a vacuum, or they cannot travel through space. Now, we're going to start looking at electromagnetic waves this week, and this is a little bit of a different type of wave. So these electromagnetic waves are essentially the visible light that we can see, and then they also include some other types of waves or electromagnetic waves. And so, for instance, radio waves, microwaves, like when you heat up your food in the microwave, heat, if you get a sunburn, ultraviolet light, X-rays, all of these are different types of electromagnetic waves. And with an electromagnetic wave, they can travel through a medium. We're actually going to be exploring that today, but they don't need a medium in order to travel. And that means that they can travel through the vacuum of space. So, for instance, why do we see light from the sun and we don't get sound from the sun? Well, sound cannot travel through the vacuum of space, but light can. And so, again, these electromagnetic waves are going to include all wavelengths of the visible light that we see. And then there's also wavelengths, again, like radio or microwave, that are non-visible, meaning we don't see them. And there is a ton of, so much of our society and technology is built on electromagnetic waves. So these are really important and something that we'll continue to explore this week and then further on next week. So go ahead, if you haven't already, please pause this video and then jot down the information for the side on electromagnetic waves. So the goal for today is to explain how light interacts with different materials. And we're doing kind of the note part right now, and then we're going to do a lab activity where you're going to get to explore this and see some of this stuff in action. So to get us started, we've got some different scenarios here, and this is very similar to the lab that you're going to be doing today. And it's basically where we're going to be taking a light and shining it on different types of materials. And so what I would like for you to do to start is just to kind of look at these different pictures and make a prediction about what you would expect to see. Like, how is the light going to interact with that material? So what happens when we shine light on a really shiny surface like a mirror? And what do you think would happen if you shine the light on a block of wood? And if you have these materials at home, you can even go and try this out. What do you think is going to happen when the light shines through a clear glass? And what do you think would happen if you shine the light in water? Well, we can predict a wave's behavior when it interacts with a new medium. And so As we get into talking about this, one of the things that we have to keep in mind is that a medium is simply any material that a wave interacts with. So this could be a solid, this could be a liquid, this could be a gas. And again, light doesn't require that, but it will move through different mediums. So light can do several different things as it travels through different mediums. Light can be transmitted, it can be absorbed, it can be reflected, and it can be refracted. And we're going to talk a little bit about what each of those are. So when we are talking about transmission, or we say that light is transmitted through the medium, this is when a light wave is going to pass through the medium. So we see this happening with glass. We see this happening a lot of times in water, where a beam of light will be able to go right through that medium and continue traveling out on the other side. And by the way, I forgot to mention this. I'm so sorry. We're actually over now on page 1.11. So you actually have a setup there where you can fill this information out in your notes and then also put a picture. Okay, so that's one option. Light is transmitted. Option 2 is that the light is absorbed. And so that would be when a light wave is taken in by a medium. And you can see here in this picture that this light is not passing through the medium. This light is being absorbed by the medium. And we see this a lot. So, that would be like if you shine light on a block of wood, well, that light's not going to shine through that block of wood, and it's going to be absorbed by it. We also have reflection. So light can, like when it hits a really smooth surface, a really shiny surface, that light can bounce right off. And so when that happens, we say that the light is reflected. Now, sound can be reflected too. And in fact, sound can also be absorbed and it can be transmitted, just like light. So for instance, when sound is reflected, that's when we get an echo. And so here we have light that is traveling to this medium. Maybe this is glass, maybe this is a mirror, and it's going to bounce right off. So that is reflection. Here's another example of where we have light bouncing back after it strikes a medium. And this is just a little bit more detail. I kind of actually already talked about this with you guys. Okay, another option here is refraction. And so this is basically what is the bending of light after it changes medium. So here we have a beam of light that is going through the air. And as it travels into the prism, it's switching from air to this medium of glass. And so that's going to actually change how that light is traveling. And so we call that refraction. Okay, so I had to go back there for just a second, my bad. So with refraction, this is when a light wave bends through a medium. So we can see that. A really great example is the bending of a wave, particularly when you look at a straw in a glass. And if you have a straw at home, I mean, go ahead and pause this video and go check it out. It's this really bizarre phenomenon that you may have noticed before. And it's because when the wave hits a new medium, it causes that wave to change speed and then bend. And so that same type of process happens with magnifying glasses. It also happens with binoculars. So that is refraction. So these are essentially the notes that I have for you guys. And this is going to give you some background information so that you can work on your lab. And I'm going to try to film a demonstration of the lab and basically provide you with sort of the visual observations that you're going to need to collect data. So what you're going to need for that, there is, I believe that is task number 4 in Schoology. There is a separate Google document for that. So once you have your notes finished up and you've had time to look through that, go ahead and jump over to your lab and I'll see you there. Bye.